So in this video, we are going over 8.4, which is, I believe, the last section of notes in our quadratics unit. So that's exciting. And the objective for today is I can solve a standard form quadratic by graphing. So we're going to be talking a little bit about what we can get from a graph of a quadratic. We've already been graphing these for a while. And then we're going to talk about what that means for the solutions of a quadratic. So let's start by talking about quadratic roots. So we have referred to the solutions of a quadratic in a few different ways. And one of the ways is calling it a root of the quadratic. But we also have some other terms for that. So let's talk about those. It says the points at which the parabola intersects the x-axis are called all of the following. So the first way we can refer to those is as the x-intercepts. The second way is zeros. So if we ever refer to the zeros of a quadratic or the zeros of a parabola, it is the x-intercepts or the roots. And then the last way we can refer to that is solutions. And you will explore these words more next year. There are subtle differences between them, but the general idea is an x-intercept is the same as a root, is the same as a zero, and is the same as a solution. Generally, x-intercepts are more referring to the graph. Zeros are referring to where y equals 0, which is still the x-intercept. And then solutions are generally the way you refer to it when you're solving an equation, which is how we did quadratics last unit. We were solving them and we did factoring, the quadratic formula, all of that stuff. So quadratics can have three different types of solutions, or three different numbers of solutions really. And I think the easiest way to see it is to draw this on a graph. So again, if we're remembering that solutions are on the x-axis and they are the x-intercepts, there are three ways that quadratics can interact with that axis, and that is how we have the different types of solutions. So the first way is you can have two solutions. You can have a positive parabola that opens up that would intersect at two places, or you could have a negative parabola that opens down that would intersect at two places. Either way, that parabola has two x-intercepts. Therefore, two solutions. You could also have a parabola that just touches the x-axis, so the vertex is on the x-axis itself, or you could have that going the other direction as well. And those are one x-intercept each. So that is where the vertex is located on the x-axis. Or the last situation is you can have a parabola that's entirely above or entirely below the x-axis. And this type of parabola has 0 x-intercepts each. And we have talked about this idea a little bit with something called the discriminant. So let's review that. The discriminant is a certain value, b squared minus 4ac. And not only is this helpful when we are dealing with the quadratic formula, but it also does give us an idea what the graph of that parabola would look like. So in the past, we've talked about how if the discriminant is greater than 0, there are two solutions, two real solutions. So that is this situation. D is greater than 0 on those first two situations. You can have a parabola that's intersecting two times, either opening up or opening down. And again, that would correspond with that positive discriminant. You can also have D equal to 0. That is where there is one solution. So that is this situation where the vertex is on the x-axis. And then you can also have no solutions. That is where your discriminant is negative. And it's 0 real solutions. You'll learn about a different type of solution next class, or next year, the next course that you take. And so again, when D is less than 0, that is a parabola that's not interacting with the x-axis at all. So I want to start by just going through and practicing finding the discriminant. And we can do that. Let's do the first three kind of together, and then you can try to do those last three and see if you can come up with those solutions. So you're going to want a calculator for this. Most of these you're going to start out by going through listing out A, B, and C. So I'm going to do that on the first one. A equals 1, B equals 5, C equals 4. I'll just do that actually for all of these if you want to go through and figure out A, B, and C for each and every one. So A equals 1, A equals -3, A equals 10. We have been doing this for a while, so hopefully you feel like you remember how to find A, B, and C. It has not been too long, but that's where you start. You're gonna need A, B, and C. Okay, so I have that written out now. And then in all of these, we're gonna find the discriminant, which again is B squared minus 4AC. You are welcome to put this into a calculator. If you do that, just make sure you put every value in parentheses when you plug it in. So it's gonna be 5 squared, again, parentheses, 5 squared minus 4 times 1 times 4. Again, you can put that into your calculator. Just make sure you type it in correctly. So again, I can type it in. Minus 4 times 1 times 4. And I get the discriminant as 9. So then you want to take that number and you want to figure out, is it the first situation, the second situation, or the third situation on the table? So D is 9. Well, 9 is greater than 0, meaning that this would have 2 real solutions. And again, that's what the discriminant tells us. So we can then assume this is a parabola that is intersecting the x-axis in 2 spots. It's not one of the other situations, so it's not the second or the third situation. Okay, number 2. So again, B squared minus 4AC. This is kind of like when you do the axis of symmetry, it helps you to write it out every single time. So B squared is 10 squared minus 4 times A times C. So we can plug that into the calculator, and then we get out 0 as the discriminant. So then again, you just need to look at the table and figure out, okay, when the discriminant is 0, what is the situation? Well, that means there is 1 solution. All right, then the last one, B squared minus 4AC. So negative 12 squared. Again, you have to plug that in parentheses or you're gonna get the wrong thing. I really want you to try to plug this one in. Make sure you agree with me on this discriminant. Minus 4 times 9. So when I put that into my calculator, I got out 0. Again, if you typed that in wrong, you're not gonna get out 0 and you need to figure out why you didn't get out 0. And then that would be 1 solution. Okay, so pause the video, try to do those last few, and then I will tell you the discriminant and we can check if you got the number of solutions correct. Okay, so on this one, the discriminant would be negative 3 squared minus 4 times 1 times 10. That gives me a discriminant of negative 31. That's actually our first negative discriminant that we've had. And so that's a situation where D is less than 1, so there are 0 solutions. Again, you can just refer to that table. On the next one, I'm going to have negative 4 squared. Again, parentheses are crucial on that. Minus 4 times 2 times negative 3. So when I plug that into the calculator, if you do it correctly, you should get out 40. That is a positive discriminant. So again, 2 solutions. You really need to know how to use that table above, but once you know that, not too hard finding the discriminant and what it means. And then on the last one, I'm going to have 5 squared minus 4 times negative 3 times negative 8. I got negative 71. So again, based off the table, that means there are 0 solutions. I tried to put an end to the exclamation point. There we go. All right, so catch up on that page. If you need to pause the video to make sure you have that section of notes done, please do, and then we can go on to the next page. Okay, so now what we're gonna do is we're gonna take what we've just reviewed with solutions, x-intercepts, discriminants, numbers of solutions, all of that, and we are gonna relate that to what we have done with this or with graphing, which is what we've been focusing on the last few days. So this is actually a question you probably could do. It's very similar to one that you had on your test. Label every part of the following graph and find the features listed. So the first thing I'm going to go through and do is just label the different parts of it. So I'm going to do the axis of symmetry first. And then the axis of symmetry, I need the equation. So it's x equals -1. Again, it's that vertical line that is cutting the graph into two symmetrical parts. I can also do, axis of symmetry. There we go. You can do opening up and down. So this one opens down, so it has a maximum. Again, all of that hopefully is review when we still remember that. The vertex is an ordered pair because it's a point. So the vertex is located here. And from the origin, it's left 1 up 8. So it's going to be -1, +8. I can find the y-intercept. It's located here. Again, the y-intercept is also a point. So it's 0, 6. And then we can also read some additional points off of this graph. They're actually put on the graph, but it might be kind of hard to see in your packet. So the points that we would normally find are on either side of the vertex. So that vertex is at -1, 8. And then we would normally count to our other x values, and then we could figure out the points. So the y-intercept is 0, 6. So -2 also has an output of 6, and you can check that with the graph. And then 1 has an output of 0, it's an x-intercept. And -3 has an output of 0 because it's also an x-intercept. So just a reminder, these are x-intercepts. The x-intercepts are going to be very important when we talk about solutions graphically on the next page. So if I had to find the solutions for this graph, it would be x equals -3 and x equals 1. Okay, so that's kind of the new concept that we're adding, is not only can you find all of these parts of a quadratic and graph it, but because of that, you can then find the solutions just by looking at the graph. And again, really focusing in on that x-axis to find your intercepts. Okay, so let's go on to the next section. So it says use the graph of the quadratic to find the solutions. So all we're doing is going through the same process we've practiced a bunch from last unit. And then we are going to find the solutions, which is that additional step. So let's start on number 8. Again, I would really focus on doing 8 and 9 with me, going through the whole process, asking yourself if you remember that process. And then I would try to do number 10 and 11 on your own and check them when I go through those. So let's focus on number 8 first. On number 8, I need to start by listing out A, B, and C. That is pretty much how we start every single thing relating to quadratics. And even next year, you are going to start with A, B, and C. You just might do that in your head. But again, we really want to make sure that we have that process down. And the way you do that is by writing them out, just so that you can show me, the person grading your work, that you're doing that correctly. Then we're going to go through, find the axis of symmetry. X equals the opposite of B over 2 times A. If I need to write that up here, I can. Because again, that is a formula that hopefully you have memorized. You needed it memorized on the quiz, but if you've forgotten it, there it is. So -4 over 2 or -2. And again, you still need to have that equals to x because it is an equation that is giving us that vertical line. So then I can go through and add in -2. It's kind of hard to see that dashed line, but you get the gist of it, and that's x equals -2. Remember, from there, we know the x value of our vertex. We can then fill in the other values like that. And then we can plug in the -2 into the equation to find the output. So y equals parentheses, watch those parentheses, -2 squared plus 4 times -2 minus 5. Again, for this part, you're just going to go straight to your calculator, plug in using parentheses. So -2 squared plus 4 times -2 minus 5. I got -9 out. So again, that was just the other step for finding the vertex. And then you're going to go through, and this is kind of hard, but let's put this on here. This graph actually only goes to 8, so I'm just going to go basically 1 unit past to get that vertex. I try not to make that happen, but sometimes that happens, so sorry on that. And then again, you're going to take your other x values and plug them in. So now I'm going to go through, copy that equation on my calculator so I don't have to type it out. And then instead of having -2, I'm going to put in -4. So when I plug in -4, I get an output of -5. I'm going to do these in red so that they're easy to tell they're not the vertex. Okay, that means when I plug in 0, I should also get out -5. Well, that's true because that's my y-intercept. Then I can copy the equation again and plug in -3. I get out -8. You can try that with -1 as well to also get -8. So let's finish graphing this and then we'll talk about the solutions. So -3, -8 is about here. -1, -8 is about here. 0, -5 is here. And then -4, -5 is here. So what we want to do, and you got to be careful with this, draw that parabola neatly. You want to make sure you get that shape as accurate as you can, because then we have to look at this and say, okay, where does that intersect the x-axis? And those are going to be solutions. So if I zoom my brain into that x-axis right here, and actually I think this is one of the hardest ones, we need to figure out, well, where is that going to intersect the x-axis? And those are our solutions. So the solutions on this are x equals, we need the x values. So this point has, or is the point 1, 0. So the solution is 1. And then the other x-intercept is at -3, 0. Or sorry, wait, that's not right. Whoop. From the origin, it's 1, 2, 3, 4, 5, -5, 0. So x equals -5 is the other solution. Again, it's a little tricky, but it's based off graphing. So if you feel like you have the graphing process down and you're confident with that, you literally have one more thing to learn. If graphing was like, whoa, what's going on, then it's going to be harder to do this, right? So make sure you feel confident on that to get those two solutions. Okay, let's look at number 9. So on number 9, again, we're going to start with A, B, and C. A equals 1, B equals -2, C equals 1. Then I can go through, find my axis of symmetry. So x equals the opposite of B, so +2 over 2 times A. That's 2 over 2, or 1. Again, I need that as an equation. Then I can add that to my graph. If I'm going too fast, please pause, just to make sure that you're staying caught up. I know I'm moving kind of quick, so x equals 1. That is the x value of my vertex. I'm going to plug in to find the y value. I can also go through and find the other points. And again, basically you're subtracting 1 going up and you're adding 1 going down. I know that's been kind of tricky for some people. Then we can find the y value, plug in with parentheses. So y equals 1 squared minus 2 times 1 plus 1. Y equals 0. Interesting, okay. So that means 1, 0, that is my vertex. So this is going to have a single solution. And then you can go through, you should have that plugged into your calculator. So you need to go through and plug in your other x values to figure out what those outputs would be. Again, if you already have this typed into your calculator, you can go through and copy those. So you shouldn't have to be doing a ton of extra work on that. You should be able to just copy those, plug in those new values, and go from there. So let's see. I got out 4. Again, I'm going to do these in red. So 4, that means at 3, the output's 4 again because that's symmetry. And then when I plug in 0, I get out 1. So I can finish by graphing this. I have 0, 1, 2, 1, -1, 4, 3, 4. Graph my parabola. Left side, nice curve, flip it over. Right side, nice curve. Okay. Then I have the x-axis, and the solutions are the x values where we're intersecting that x-axis. So that is going to be actually the vertex on this one. Again, it's located at 1, 0. So the solution is just one solution. The discriminant on this would be 0. X equals 1. So again, once you know your x-intercepts, then the solutions have the x values of those. They're just written as an equation. Okay, let's move on to 10 and 11. So on number 10, same thing, list out A, B, and C. So A equals -1, B equals 2, C equals -3. Axis of symmetry, X equals the opposite of B all over 2 times A. So I can simplify that -2 over -2 or 1. Again, I need that as an equation and I can graph it. So that's actually the same axis of symmetry as the last one. Kind of interesting. Again, I do like to label my axis of symmetry. Did I do that on the first? Oh, I've done that every time. Yes, go me. There we go. So 1. I can then do my other values, 2, 3, 0, -1. I can find the output of my vertex now. So we plug in that vertex x value using parentheses. So negative parentheses 1 squared plus 2 parentheses 1 minus 3. The parentheses are so important. They need to be in that exact location for you to get the right output. So when I go through and type those in, and I'm typing right here with you, I get out -2. So I can add that to my graph. It should be on my vertex. So if it's not, or sorry, it should be on my axis of symmetry. Remember that vertex and axis of symmetry always line up, which is nice. Then I can go through, find my other values by plugging in the other ones. So I can plug in 0. Again, I'm just copying these in my calculator. I get out -3. Again, that's going to be symmetrical on both sides. Then I can plug in -1, or you could plug in 3. Whichever one, as long as you are typing it in right, it should not matter. I get -6 and -6. So then I can graph it and find my solutions. So I have 0, -3, 2, -3, -1, -6, and 3, -6. So this one's kind of interesting. It's a parabola that opens down. And again, all we're looking for is how many times does it intersect the x-axis? And that would be the solutions. Well, this one never intersects the x-axis, so it has no solutions. Ta-da! Okay, so go ahead, pause the video, try to do that last one on your own. Be very careful on identifying A, B, and C because it only has 2 solutions, and then we'll go over it. Okay, so on this last one, we have A equals -1. Now look, B is 0 because 4 does not have an X with it. And then C is +4. So if you mess that one up, erase it, go back and fix it. I know it's hard when there's only 2 terms to find B or C, but in this one, B is 0, C is 4. Then we can find our axis of symmetry. So X equals the opposite of 0 all over 2 times -1. That's like 0 over -2, which is 0. Again, as an equation, that is going to be the y-axis, so we can put that on the graph. And it is y equals, sorry, x equals 0, silly goose. And then we know that's our x value. We can then take that info and get our other points. So I'm going to have 0, 1, 2, -1, -2, a little mental math there. You can then go in and plug in for the output. So y equals opposite of 0 squared plus 4. So you get out y equals 4. And then again, you can type that into your calculator. You just have to use the parentheses. Are we getting used to that idea yet? It's super important. So 2 has an output of 0, meaning, or sorry, -2 and 2 have an output of 0. And then when I plug in -1, or again, you can plug in +1 because the symmetry there, you're going to have 3 and 3. So I guess I didn't put my vertex on here. Oh my goodness. Here we go. There's the vertex. I have -1, 3 and 1, 3, and then -2, 0 and 2, 0. So when I graph this parabola, smooth curve on one side, smooth curve on the other side, I need to find the x-intercepts, which again, we're going to look at the x-axis. You need to figure out the 2 x values where it crosses, and those are going to be the solutions. So on this one, the solutions are x equals 2 and x equals -2. And there we are for today's lesson. So make sure you have that completely filled out. If you missed anything, you can use the key or rewind in the video. and then you are working on the homework the rest of the hour. Thank you so much.